In this problem, I've given you the sign chart for f of x as well as a zero and vertical asymptote. And then the other important piece of information is what happens to f of x as x approaches infinity. And in this case, that limit is going to be zero, which tells us that we have a horizontal asymptote at y equals zero. So we have this horizontal asymptote as well. Then you're asked to sketch a graph of f of x. Well, on the left-hand interval where it's positive, we have to come out of that zero, stay above the x-axis, but eventually get close to our horizontal asymptote. In between, where our interval is negative, we got to come out of that zero and get close to our vertical asymptote. In the last interval, we have to stay on the positive side of the x-axis, so up above. Coming from our vertical asymptote, we need to get over to our horizontal asymptote. And that's the sketch of the graph of f of x. For g of x, we have a similar sign chart. We got a zero and a vertical asymptote. But this time, the limit as x approaches infinity of g of x is now going to be positive 2, which means we have this horizontal asymptote at positive 2. However, when we graph it on this first interval, we're going to want to come out of the zero and get close to our horizontal asymptote, staying above the x-axis because we're positive on this interval. In the middle interval, we're negative, so coming out of the zero, we have to get close to our vertical asymptote, but stay below the x-axis. On the last interval, we're going to want to stay above the x-axis the entire time, so coming out of our vertical asymptote, get close to our horizontal one. And for the last function, we have a similar zero and vertical asymptote, but this time the limit as x approaches infinity of h of x is going to be negative infinity, and that's where we have this oblique asymptote. So if we're going to sketch this graph on the left interval coming out of the zero, we want to get close to this oblique asymptote. In the middle interval, same thing, we want to get close to our vertical asymptote, staying below the x-axis, which puts us down here. As we pass over that vertical asymptote, we still have to remain negative, which means staying below the x-axis. We can come up and get close to our oblique asymptote, staying underneath it the entire time. That'll keep this branch below the x-axis as well for its entire, the rest of its graph.